So yesterday someone broke into my workshop and stole all of my homemade cookies. Fortunately for us, I know exactly where they are. The problem is how we're gonna get them back. We need to find a way to make 1500 volts. As you probably read the title for this video, you know that we're going to be using AA batteries to get our 1500 volts to get our cookies back. If you got some experience with batteries, you know that when we connect batteries after each other, or in series, the voltage multiplies. So let's say we have 10 batteries connected in series. That gives us 10 batteries times 1.5 volts from each battery. That gives us a total of 15 volts. But in this case, we're using 1000 batteries, which is going to be challenging to connect up. But before we figure that out, we're going to measure each and every one of these batteries, because as these are used batteries, some of them are broken or completely out of charge. So what I'm hoping to find is some batteries with either half or full charge. So I began measuring all the batteries I had, trying to figure out which ones were actually good and which ones were just useless. I ended up splitting them into 4 categories. First, everything under 1 volt. Those I consider to be either completely dead or just broken. Then category 2, slightly better, around 1 to 1.2 volts. These I estimated to have maybe 0 to 25% charge left. Not really great. Category 3 was in the 1.2 to 1.4 volt range, which I guess to be somewhere between 25% to maybe 75% full. And finally, category 4, everything above 1.4 volts. These were the ones I considered to be properly charged, around 75 to 100%, but measuring the voltage alone doesn't necessarily mean the battery is actually good. Ideally, I should be measuring them under load, because I could have a battery that reads 1.4 volts, but the moment I put any load on it, the voltage would drop significantly. And the reason for that is the internal resistance of the battery. The higher it is, the worse the battery performs under load. As the battery gets older, the internal resistance increases. They start to sulfate, dry out, and just degrade over time. And in my case, I'm using only used batteries, so there's a really good chance a lot of these batteries have a really high internal resistance. But I'm not going to be measuring that, as that would take so much time. So instead, I'm just going to have to expect a significant voltage drop when I put all 1000 batteries under load.
Now everything is measured, or every last one of them are measured, and I'm going to bed. I'll see you guys tomorrow.
So this is the idea I got for how we're going to connect 1000 batteries in series. I'm basically just going to put 4 batteries in each row, 1 row going up and 1 row going down with a cable at the end to connect them together. So I'm going to do that all the way around. So at the start and the end of this battery cell, we would have the potential of, I think it's 156 batteries this cell contains. So yeah, we are going to be needing 7 of these. And one of these takes like 2 days to print, so I got 14 days of printing. Yeah. So I'm going to complete this battery cell and connect everything up and see if the concept works and we get the right voltage output. After 40 hours of printing to make the first battery holder, I could begin the assembly. My idea was to make short cables between each row to connect them together and hope that the stripped end of the cable would be enough to make a good connection. As I wasn't using any springs to ensure a good connection, I made these battery holders in a way that they would clamp all the batteries together using threaded rod. But while I was putting all the batteries in the cartridge, I found a big design mistake. So I made a mistake when I was modeling these battery holders. You see, each row is sized to fit the battery exactly, and I mean so exactly that it kind of widens the whole row slightly. And when you try to widen all the rows all the way around, the center circle kind of wants to stretch a little bit out. And since this is PLA, it kind of just broke instead, because you can't stretch PLA. But to fix this problem, I basically just increased the size on each row slightly so we wouldn't have that stretch problem anymore. But the other problem is, I was so confident in this design that I just started mass producing all the battery holders I need. Which is really annoying, but I can't blame anyone other than me for that. So I'm gonna wait for this print to finish up and then assemble it to see if everything fits together well. And if it works, then I can mass produce it. After another 20 hours to wait for a new battery holder to finish printing, I could begin the assembly again, using some heat inserts for the attachment points to the top and bottom lid, and since I didn't have any proper soldering tip to melt the heat inserts into the plastic, I had to heat up the tip and use the other end of it to insert them. But in retrospect, I see that I could have just used a lighter or a blowtorch instead. With that out of the way, I installed the bottom lid from the first cartridge that broke and then put in all the 144 batteries. This time no deformation happens and I could put on the top lid and do some tests. Alright, now for the exciting part, connecting everything back together. Hopefully it's gonna be as I expected. Everything working well, but we'll see about that. Okay, I don't know if I have a connection with all the batteries, but we can measure it and check. For some reason, some batteries are warm, so either they got short-circuited or there's an internal battery failure, but yeah, they are warm. Really warm, actually. So it turns out I didn't think properly while I was connecting up the battery rows. I connected them in a way that each battery row would short circuit, which would draw a lot of current. And as a result of that, the batteries would start to heat up. So as a quick fix on the prototype, I drilled new holes that would align the cables correctly to make the intended serial connection. But as I was about to do the new test, I couldn't find a screw that clamped down the top lid, ensuring a good connection.
It was...
It's real annoying looking for something for several minutes, only to discover that what you've been looking for is right in front of you. With the top lid fastened, I did some measurements to see if the serial connection worked. But as I was measuring, I smelled something unusual. It kinda smelled hot and chemical. I can't say that. So immediately I suspected it was the batteries again.
This is not good. Oh, something's really hot. Shouldn't have made so many screws. Ah. Ah. That's hot.
Yeah, crumbled. Ow! It's so hot. A few of the batteries are like insanely hot, and I just don't get what's happening.
Well, what's actually happening isn't too complicated. Even though I drill new holes that would create the serial connection, I use the holes that would create a short circuit again, without thinking properly. So to prevent that mistake again, I taped over the holes I shouldn't be using. So with all of these stupid problems out of the way, I put on the top lid again, using the right holes, of course, hoping to see a good connection all the way through. But that wasn't the case, since the lid I made was too flexible and would bend too easily. Which is a problem as some AA batteries are slightly higher than the other, making the highest battery bend the lid slightly and breaking the connection to the other batteries aside. In an ideal scenario, I would have used springs to combat this problem, but in order to get 254 springs for each row on the 7 cartridges I need, that would cost between $200 and $300. Yeah, so naturally I would continue on to see if I could either find a cheaper solution or something out laying around that I could use. After some more time to figure out a new solution for the connection problems we're having, and also getting some really good ideas from my dad, I ended up using small screws. This way I could fine-tune each row to connect with the batteries, and therefore creating a more reliable connection. Yeah, whatever, this time it's gonna work. It's gonna work this time. And here we are. And since I'm using the old model, the holes alignment on the new lid doesn't go along with the old lid, so I gotta try to make a way around that. Actually, I gotta be more careful this time because all the screws are gonna be live this time, and if I touch these two and it's all connected, I'm gonna get like 200 volts in me from batteries, which, yeah, I don't want. This is what I meant with the holes doesn't align. This is the old lid, and this is the new lid, the bottom lid. So this is the actual one I'm going to be using, but just for the sake of not having to connect all the cables on underneath again, I'm going to do it like this for now. Now you could see the measurement as well. Yeah, so that's plus and that's minus, and we get nothing, which is expected because I haven't adjusted any of the screws yet. So I'm gonna do that and then try again. Oh, this is gonna take a while. I don't know what it is. I think I have a connection all the way up here because when I connected this screw, it sparked or it arced over the terminal, which I don't know if is a good sign or not. So I'm just gonna try to finish this thing without touching anything. Okay, that's definitely not gonna be. There's a short circuit somewhere. It's hot. Is everything hot? No, it's only these. Oh, I see the problem. Actually, get the GoPro for this. There's a small. Yeah, here. That's the problem. Oh. Yeah, well, that's taken care of. Nothing worse. And that explains the spark. So I guess we'll continue. Oh, there we go. It's so much precision in these screws because if I tighten them too much, it kind of lifts the whole lid and that makes all the batteries around that screw that's too tight kind of get lifted up. I can't tighten it too little and I can't tighten it too much. So it's a lot of precision in this kind of battery module. Still hoping it's gonna work. Let's get on with the measurement. I'm not gonna be convinced that this is gonna work first try, but yeah, well, it didn't. But where is the fault? The problem wasn't too bad. As I mentioned earlier in the video, the top lid bent quite easily, breaking the connection with the batteries. But in the new model I already thought about this and made 8 holes for the threaded rod, which would help clamp down the top lid at more points, making sure it won't bend as easily. So I began cutting 8 pieces of threaded rod to install them on the prototype. But since I was still working on the prototype, this model didn't have 8 holes as the new ones. So I had to drill new holes in the old top lid. Finally, the first cell is complete and we are measuring 208 volts, which is great, but I don't know how stable the connection is. So I don't know how it would perform under load, but yeah, we'll get to that. This motor is rated for 5 volts, I think, so okay. Oh, wow. It's really stupid, but it's really fun. Okay, let's see how much it could actually take. Oh no, it broke. Well, I got plenty more. Oh. Well, anyway, we kind of get an idea of how much energy we have from just, I think this is 154 batteries. And we're gonna times that with 7. Which is going to be insane. So, a lot of building. So this is what 200 hours of building time gives you. 1008 to be precise, batteries connected in series. And theoretically, we should have about 1500 volts between these two terminals. Oh wow, that... I expected something much bigger, but... Since my multimeter can't measure 1500 volts, it can only measure up to 1000 volts DC, so I can't measure between these two terminals. So what I did was measuring each and every one of these cartridges, and I added them up to roughly 1398 volts, if I'm correct. I'm gonna put it on the screen, which I would expect give us a slightly bigger arc, but yeah. I guess all of these precautions wasn't too necessary, but still like to be on the safe side. And this is probably a good time to mention that you shouldn't be doing this at home, but yeah, I think I know what the problem is. As I said earlier in the video, all of these batteries are used, so they would have a really high internal resistance. So when I put load on all the batteries, the voltage would most likely drop significantly, so that's probably what I'm experiencing. I can't measure the full voltage drop, but I could take a rough estimate over all of these 4 when I short circuit the electrodes. Oh wow, that's way more than I expected. It's like over half of the voltage is dropping. Now let's see how a small 5 volt motor holds up against, well, I don't know how much voltage because we're getting so much voltage drop, but here we go. It's actually holding up. That's a great motor. Ah, geez. Yeah, it's broken. I'm surprised it held up that long. It's a good motor. So this is a 15 kilo ohms resistor, which is rated for 0.25 watts, but it's definitely not meant for this kind of voltage. Oh. This wasn't too impressive. What would be impressive is getting our cookies back, so I'm gonna get the box. All right, now the box, and well, yeah, it started raining so much while I was filming, and now everything is wet. And it's really not that good working with electricity while everything's wet. So I'm gonna take some precautions. Not that I need hearing aid for wet electrodes, but it's for the box.